In this video, I'm going to teach you about something called the first welfare theorem that most economists would probably argue is the most important single result in economics. So I want you to pay special attention to this material because it's going to teach us something very, very important. So let's look at in detail why this result is true. Now, the logic of the result is if an allocation is a market equilibrium, it is Pareto optimal. I'm going to prove it with you using the contrapositive, with the idea it's going to show you that if alpha is a market allocation, a competitive market allocation, a competitive market equilibrium, and is not Pareto optimal, then there is a contradiction. There is something wrong. That makes no sense. That's the logic that I'm going to use. Okay? So let's suppose that we have an allocation alpha star and a price P star that are a competitive market equilibrium. They are actually a competitive market equilibrium. Now, I claim that we know that P star must be greater than 0. How do I know that P star has to be greater than 0? Because if P star is greater than 0, given that the marginal benefit for individuals, for every consumer, is greater than 0, they would want to buy an infinite amount of good Q, which would not be an equilibrium. Now, suppose that alpha star is not Pareto optimal. Okay? Let's see what happens. Then there exists another feasible beta, allocation beta, which is Pareto improving. And this implies two important things. This implies, first, that for some I, for at least one I, one consumer I, U of what he gets at allocation I is greater than what he gets at the allocation in the market. But this also implies on itself that, this is a critical step, P star QCI of what he gets at the new allocation plus MIC of what he gets at the new allocation. Notice that this is just the cost of what he gets at the new allocation beta has to be greater than P star of QIZ alpha star plus MCI of alpha star. Notice that this term on the right is what the consumer gets. Sorry, what is the cost of buying the bundle Q and M that he consumes at the equilibrium allocation? Now, this is critical, and you need to understand this to understand the logic of the proof. Why is it that for the individual who's strictly better off, the new allocation has to cost more? Because if it didn't, the consumer could have bought it at the same cost as he did before or less, and he would have gotten higher utility, which means that the consumer could not have been maximizing at alpha star. In other words, if this is not true, we get a violation of individual utility maximization for this individual I. Now, the fact that there is beta that is Pareto improving, it also implies too that for everyone, for every consumer J, U of J of beta J is greater or equal than U of J of alpha J star. We know that a movement to a Pareto improvement allocation cannot hurt anyone. Hear this. Now, but this implies, for a very similar logic, that P star of QCJ at beta plus MCJ at beta, that's how much it costs to buy the allocation at beta, at prices P star, has to be greater or equal than P star QC J of alpha star plus MC J of alpha star. Now, why does this have to be the case? Because if this condition was violated, the individual would also not be maximizing at the allocation alpha star that we are arguing is a competitive equilibrium. So as long as alpha star is a competitive equilibrium, these implications follow. Now, I'm going to continue the proof here. This together implies adding across subjects that the sum over I of P star QCI of beta plus the sum over I of MCI of beta has to be greater, strictly greater than the sum over I of P star Q IC at the market allocation plus the sum of I MIC at the market allocation. Notice that all I'm doing is adding the left-hand side and this right-hand side of these inequalities for every consumer, and we get this. Now, we have that this has to be equal, and this has to be equal by feasibility to the following. We're just going to substitute the feasibility constraint for M, and we're going to get that this is going to be equal to the sum over I of P star QIC beta plus the sum of the endowments minus the sum over all the firms of the cost for firm J of producing whatever it is required to produce at beta. And this is equal, I'm going to write it down here because I don't have enough space, to the sum of P star of QCI of alpha star plus the sum of WI minus the sum over J of CJ QJF at alpha star, whatever the firm is required to produce at alpha star. Notice that all I'm doing is unpacking this term into this and this term into this using the feasibility constraint. But notice what happens. This term and this term cancels because these are just constants on both sides, and not what we get. This term is just the profits, the sum of the profits of the firms at allocation beta, and this is sum of the profits of the firm at allocation alpha. So this implies that the sum over all firms J of the profits pi of J at beta, remember these are profits, is greater than the sum over J of the profits of all firms at alpha star. But this is a contradiction. This contradicts profit maximization at alpha star, which imply alpha star not a competitive market equilibrium. And that concludes the proof. Think about the logic of the proof. What we have shown is that if something is a competitive market equilibrium, but it is the case that is not Pareto optimal, then we can derive an implication that shows that the firms were not maximizing profits at alpha star, which of course cannot be a competitive market equilibrium. Therefore, we get a contradiction. Therefore, the supposition that alpha star is not Pareto optimal has to be false, and we establish the result. Now, I'm going to give you two separate intuitions about why the first welfare theorem is true that look very different from the proof and hopefully will give you an enormous amount of economic intuition. So the first is going to be an intuition that I call the invisible hand of the market. And if you are a reader or a connoisseur of Adam Smith, you will recognize this reference. So the idea is the following. Let's compare what market forces do with what are the properties, the necessary properties for Pareto optimality. Okay? Now, what do we know? We know that the market forces do. We know that market is going to settle at a P star and alpha star, a price and allocation that has the following properties. With, first, the allocation is feasible. And we know this from market clearing. The market needs to clear at P star, and that means that the allocation is feasible. But more interesting, we know that at P star, the following is true. The marginal benefit for any consumer is equal to P star is equal to the marginal cost for any firm. Notice that I'm going to do this intuition only for interior allocations. It's an intuition, so I don't want to worry about complicating things with the general case. We know that the following property is going to satisfy for every pair of consumers I and firm J. And this is very important. Now, where does this come from? We know that this is given by the utility maximization motive of the consumers. When in the process of maximizing utility, they don't care about prices, don't care about anyone else, but they end up choosing a level of consumption at which this is true. Similarly, firms don't care about anything else but their profits, but in the process of doing that, while they taking the price P star as given and engaging in profit maximization, they end up setting out a quantity that solves that equation. Okay, so we know that the market does that. But now, as the guy from the Big Bang Theory will say, Kazinga, we have the result. Because let's see why. What does property 1 require? Property 1 requires that the marginal cost be equal among any two firms that produce a positive amount. But notice what's going to happen. Take any two firms. Firm 1 is going to sell, let's say, firm J, its marginal cost equal to P star. Firm 2 is going to sell its marginal cost equal to P star. So in the process of current utility maximization, they are equalizing the marginal cost, which is what is necessary for Pareto optimality. Please let me emphasize, and I'm going to come back to this. This is very important, very, very important. The firms couldn't care less about each other. All they are doing is maximizing profits. But in the process of maximizing, this guy sets this to this guy sets this to this, and therefore they equate the marginal cost. Now, this market condition also implies property 2. Why? Take any two consumers. Consumer 1, let's say, is going to equate its marginal benefit to its price star. Consumer 2 is going to equate its price star to its marginal benefit. And again, indirectly, in the process of engaging in utility maximization that generate this equation and this equation, they end up equating the marginal benefits. What about property 3, the one about overall production efficiency? Well, that just follows, is written here. Take any consumer, I, is going to equate this by utility maximization. Any firm is going to equate this by profit maximization. And indirectly, we are equating all of this by the invisible hand of the market. I want to emphasize one thing, that this is, I know I've repeated like 4 times in the last 2 minutes, but it's very, very important. The fact that all of these Pareto optimality conditions, like equation of marginal cost, marginal benefits, and across marginal benefits and marginal cost, follows from the visible hand of the market. Everybody's trying to do whatever they want, maximize utility or whatever, maximize profits to do as well off for themselves as they can while ignoring everyone else. And indirectly, at the market equilibrium, it just happens that they end up picking an allocation through this market process of coordination that satisfies the Pareto optimal conditions. So the invisible hand of the market, this invisible hand of the market that economists have referred to for about 2 centuries, generates a Pareto optimal allocation, and now you know exactly why that is the case. Let me give you another intuition that is emphasized in basic books and is often very useful for working out problems. So let me start with a result, which is that social surplus is maximized over feasible allocations at a competitive market equilibrium allocation alpha star. In other words, whenever you compute an allocation that is a competitive market equilibrium, you're also computing an allocation that maximizes social surplus over all feasible allocations. Now, why is this the case? The proof with everything that you know so far is trivial. Step 1 is we know that the first welfare theorem implies that alpha star is Pareto optimal. And the second thing is we know from earlier that Pareto optimality implies or is equivalent to the maximization over gamma feasible of social surplus of gamma. We've shown this before. So therefore we know that a competitive market equilibrium must maximize social surplus. But beyond the statement, there is a graph that I want to do for you that has a lot of economic intuition. So this is the amount consumed in the market. This is dollars per unit. And I'm going to draw the aggregate demand function and the aggregate supply function. And remember, this is from this perspective, looking at the quantity demand as a function of prices, and we get the total quantity produced in the market, Q star, and we get the market price. Okay? So far, nothing new from last unit, but now notice the following. Remember from our theory of the consumer and our theory of the producer and what we have done before, that this locus of points is also the aggregate marginal cost curve as a function of total production. And that's when we look at the locus as a function of Q. And that this one is the aggregate marginal benefit as a function of Q. Okay? And we saw the interpretation that was the marginal cost of producing another unit for the group and the marginal benefit of producing, of giving another unit to the individual with the highest marginal benefit. Okay? Now, from this, we know that intuitively, the allocation that maximizes social surplus is going to be the one at which these two cross curve. Why? Because social surplus, it cannot be down here because, let's see, at this point, the aggregate marginal benefit exceeds the aggregate marginal cost, so you should socially, you could increase total well-being by increasing production of another unit. So what we know is that this point is also the point at which is socially optimum, call it that, in the sense of maximizing social surplus. And we know that this price is the point at which the aggregate marginal benefit and aggregate marginal cost cross. So this price is also going to be equal to the aggregate marginal social benefit, sorry, the aggregate, I apologize, marginal cost at the optimum, and is equal also to the aggregate marginal benefit at the optimum. These two things have to be equal at the optimum, but it also happens to be equal to the market price. So notice one beautiful thing, that not only is the market, the invisible hand of the market, leading total quantity at the point that maximizes social surplus, but the price itself is telling you something beautiful, which is what is the aggregate marginal cost of another unit or the aggregate marginal benefit of another unit at the optimum. So you learn something about the marginal social cost and marginal social benefits.